All right, this is the fourth video lecture for Module 1, and in this one we're going to be talking about GIS, Geographic Information Systems, and in a sense, thinking geographically. So the first place we need to start is with a gentleman by the name of Waldo Tobler, one of the early geographers of, well, I should say really mid 20th century. And he, in a sense, gave the first and really only law of geography, which is simply that everything is related to everything else, but near things are more related than distant things. And what he's really saying is that all of kind of the human landscape influences all other aspects, but the closer two things are together, the more they tend to be related. Again, if you think about this quite simply, even something as simple as the elevation of a surface. If we're walking along, most of the time we're stepping and it's very similar, one step to the next. But if I went 1,000 miles away, it's very likely that the elevation is considerably different. So the closer two things are together, the more they're alike and the more they influence each other. The farther apart they are, the less they're likely to be alike and the less they influence each other. Now, what this allows for then is what we call spatial analysis. And so that's where we get into this idea of the geographic information system. And if I look at this, I'm going to just very quickly look at this idea of interaction. So if I'm going to click on this, this is an example of, we're going to look at quite simply donuts. Okay, so what you see here is Dunkin' Donuts versus Starbucks. And in fact, there is a very strong aspect of Dunkin' on the east and a very strong influence of Starbucks on the west. And then as we move kind of away from each other, in other words, here's like, if you will, a home, the influence of that home becomes less. And the same is true here, and we begin to kind of have this middle ground where both are true. And so GIS, Geographic Information Systems, and in fact Tobler's law of spatial interaction can be seen here. We can also see this with some of the fast food patterns. In other words, when we look at fast food, and in this case what we're looking at are all of the major fast foods in the United States, what we can see, and again, so here we're looking at subways, and the other thing that we're going to see is that, again, subways cluster, but they also cluster where there are people, or more people out here. And if we look at all of these, what we're going to see is that, again, fast food tends to have a very similar pattern. Not perfectly similar, as you can see here, but they tend to have fairly similar patterns, and they tend to cluster about things that are like them. In other words, Pizza Huts are around Pizza Huts. So we can think about, again, this idea of interaction and clustering and avoidance. Okay? And again, as we move through the semester, we're going to get more in detail. But what we just showed you was an example of a geographic information system. Okay? Now, geographic information systems are ways of dealing with what we consider spatial data. And so when we think about anything that's spatial, that means that it has location associated with it. And the idea of location can be understood in a couple of different ways. So location is where something is. An enumeration unit is an area where we count things in. And then we're going to talk a little bit about bias and on spatial data or space and how we correct that. All right, so first of all, location. All of you kind of deal with this every day. You have an address. An address is a form of location. But remember when we talked about coordinate systems, we can also have, and again, geographic information systems oftentimes will take an address and make it, if you will, standard, and then it turns this address actually into a pair of coordinates, again, a latitude and a longitude. This allows the system to analyze or evaluate where something is. So location. Okay. Now, once we have a where, for example, U, we can then begin to put all of the U's that have a certain characteristic into an area. That's what we mean by an enumeration unit. So in the case of this map, it's how many people in a county So a county becomes an enumeration unit, a unit for numbering or counting. And so in this case, all of the information about people is aggregated or collected in a county. And the shape and size of that enumeration unit is very important. In fact, we can change outcomes by changing the enumeration unit. If I look at county level enumeration as opposed to state level enumeration, we're going to get different ways of seeing the map. Okay? So why does it matter? Well, the thing that I want you to understand is something called the modifiable area unit problem. So if we think about this, these are people. Let's just say those are people. If I do, well, how many people in enumeration units that are shaped like this one has 2, this one has 3, this one has 1, this one has 4. But if I make the shapes different, all of a sudden the top has 4 and this one has 1. Well, in this case, the lowest value was down here, now it's in the middle. If I change the shapes again, the lowest is way up here in the corner, the highest is down here. So the shape that I put the counts in matters, and it matters a lot. In fact, one of the classic examples of that is what we call gerrymandering. If we change the shape of congressional districts, we can change who wins. And in fact, most states, this is an important idea. And again, later on when we get into political geography, we're going to see that this idea of changing the enumeration unit changes outcomes. And there are important implications to that. Again, same idea that I showed you before. If these are precincts and I draw them this way, blue wins. If I draw them this way, red wins. And there's no rule that says why the shapes should be the way they are. All right, now the next piece though is sometimes we can make maps or analysis do different things. And so what we want to do is normalize those enumeration units. And so oftentimes what we will do is we will make, and again, normalization for your notes is a way of making things comparable across space. Because again, think about a simple example. If I were to compare populations between Rhode Island and California, of course California is going to have more population because it's bigger. Well, sometimes we don't want the bigger aspect to come out. We want to know something about people and be able to compare them. And so one of the most common ways of normalizing data is what we call density. So again, if we look at this, we have 3 hypothetical areas, one which is a half mile on a side, one which is a mile on a side, one which is a third of a mile. And these are the number of people in each one of them. Well, here we say, well, this has the most people, this has the least, this is somewhere in the middle. But if I divide the number of people by the area, then I can compare each one of these in terms of the population density. So normalizing by area is density. I can also, though, normalize by some type of relevant population. In other words, sometimes it's not okay to look at the number of people simply. I have to look at a certain kind of people. For example, today, it's people that might be vaccinated. So again, this is the number of people, total people in the labor force. But what I want to know is what percent is unemployed? Well, I have to know how many people there are, and then I have to apply the unemployed to that, and that is what we call normalization by relevant population. Unemployed by the relevant population, which is people in the labor force. It wouldn't make much sense to apply this to all people because, for example, babies don't work. We can also do that by a quite simple, what we would call a value within the unit. So for example, whenever we look later on, we're going to see just median values. Median is just the middle value within a population or area. So median income. Or lastly, we can do a summary value across all. And this one, the one is easy to remember on this, is so a comparison to the US average. So we can take every county and see where their income compares to the US average. So these are ways of normalizing our data, making it comparable across different locations. In the next video, we're going to be talking a little bit about global navigation satellite systems. We'll see you then.